Okay, a few practice problems from the Pythagorean theorem quiz that we will have next week. First question, simplify the square root of 60. Square root of 60, we want to find a perfect square that divides into that radicand, so 4 divides into 60 15 times, so we write that as square root of 4 times square root of 15. Square root of 4 is equal to 2, so we get an answer of 2 times square root of 15. Next problem, when we have a square root in the denominator, such as 12 over the square root of 3, we multiply by the square root of 3 over the square root of 3, which gives us 12 times the square root of 3 over 3. Just by definition, the square root of 3 times square root of 3 has to equal 3. And then we have 3 goes into 3 once, 3 goes into 12 4 times, so we get 4 times the square root of 3 for that answer. Next problem, using the Pythagorean theorem, solve for the value for x. So we have a squared plus b squared, start that again, a squared plus b squared, the sum of the squares of the two legs, equals c squared, the square of the hypotenuse. So we have 64 plus 225, that equals x squared. So 289 equals x squared. We take the square root of each side of the equation. Square root of x squared is equal to x, because we're only dealing with positive numbers for the geometry part of the problem. And the square root of 289 is 17. And the next Pythagorean theorem problem. Actually, the next problem is the next two problems. First time we're going to express the answer in simplified form. So we have 3 squared plus x squared equals 7 squared. 7 being the hypotenuse, that's why it's on the right hand side of the equal sign. So we have 9 plus x squared equals 49. We subtract 9 from each side of the equation, we get x squared equals 40. Therefore, the square root of each side gives us x equals the square root of 40. But that answer is not simplified, so we have to find a perfect square that divides into 40, which happens to equal 4 again. So we have square root of 4 times square root of 10 gives us an answer of 2 times square root of 10. Now the same problem, we can have exactly the same work, so I'm just going to copy that down below. And it says to solve for x, it's the same triangle, but sometimes instead of trying to state the answer in simplified form, sometimes we're going to want to state the answer as a decimal. So simplifying this, we still get x equals the square root of 40, but instead of simplifying it again, we're going to use a calculator to figure out an approximation for the square root of 40. So opening up the calculator, we have the square root of 40 equals approximately 6.3, rounded off to the nearest tenth, that is. So we get 6.3. So the same answer, okay, it can be expressed two different ways depending on the directions. To the nearest tenth, 6.3, in simplified form, 2 times square root of 10. Next problem, using the converse of the Pythagorean theorem. Now we want to say a squared plus b squared, does it equal c squared? And if the answer is yes, then it is a right triangle. If it is no, as we'll see in a couple of other problems, we will distinguish between acute triangles and obtuse triangles. So the one restriction is c has to be the largest number. So 13 is obviously the largest number here. We have 5 squared plus 12 squared. Does that equal 13 squared? So 25 plus 144. Does that equal 169? In this case, 169 does equal 169. When the two sides are equal, it is a right triangle. Next problem. Sometimes sides are irrational numbers as well. Still could be a right triangle. This one's not going to turn out to be a right triangle. But just identifying the longest side is difficult. So the easiest way of finding which side's the longest is if you're allowed to use a calculator, which you will be for the next quiz. Just open up your calculator and you put into the calculator 2 times square root of 2. And we get approximately 2.8. So let's copy that down. So this first number is approximately 2.8. The next side already is an integer, 5. So far 5 is definitely the largest. The last value, 2 times square root of 10, we'll use the calculator again. 2 times the square root of 10 is 6.3 something. So obviously, going back to the problem, 6.3 is the longest side of that triangle. So now that we've identified the long side of the triangle, and that's not the only way you can figure out which side's the longest, but we'll just go with that for now. 2 times square root of 2 squared, added with b squared, 5 squared. Does that equal the longest side squared? Well, taking 2 times square root of 2 and squaring it, you should be able to go 2 times square root of 2 times 2 times square root of 2. I like to change the order for people that have trouble with something like this. And we have 2 times 2 is grouped together. That equals 4. Square root of 2 times square root of 2 equals 2. And 4 times 2 equals 8. So that's one way of getting the answer. 5 times 5 is obviously 25. Does that total equal 2 times square root of 10? Once again, if you're allowed to use a calculator, you can do work equivalent to what we have down the bottom here on the calculator. And for most people, that would be a whole lot easier. So let's look at a calculator. And we have, we'll clear this previous work, and we'll go 2 times square root of 10 times 2 times the square root of 10. In other words, 2 times square root of 10 squared multiplied by itself equals exactly 40. So the calculator, even though it approximates for the square root of 10, when it does all of that calculation, it gives you exactly 40, which is the exact answer. So even though you might have thought we'd end up with an approximation, we didn't. We ended up with the exact answer. So we'll get rid of everything down here. So we have some room to work with. And we have 8 plus 25 is 33. That obviously does not equal 40. So now we have to figure out, because we just realized that it's not a right triangle, okay, not a right triangle, which type of triangle is it? So you look at the square of the longest side, which is on the right-hand side of this inequality. Because that means 40 is larger than 33, because the square of the longest side was too big to have been the square of a hypotenuse for legs of length 2 square root of 2 and 5. This is too big on the right-hand side. Too big means it is an obtuse triangle. Okay, one more problem. Sides of length 5 square root of 3, 5, and 9. First thing I want to do is figure out which side's the longest. So we'll go to the calculator again, and we'll go 5 times the square root of 3 is 8.6, or 8.66, so therefore approximately 8.7. But in any case, that first value is approximately 8.7. 9 is the largest value. So we want to work with exact values here. We don't want the approximation. That was just to figure out if the first number was larger or smaller than the 9, which is obviously larger than the 5. So we have 5 square root of 3 squared plus 5 squared. Does that equal 9 squared? 5 square root of 3 squared. 5 times square root of 3 times 5 times square root of 3 is 5 times 5 times square root of 3 times square root of 3. Or you could be using a calculator, but 25 times 3, that first value is 75. Plus 25. Does that equal 81? And let's get rid of this scratch work at the bottom. And 75 plus 25, 100, obviously does not equal 81. So therefore it's not a right triangle. The square on the right hand side, the square of the longest side, is now too small to have been the square of a hypotenuse. Small means it is an acute triangle. Hope those problems help, and I'll have another half to this quiz review. Good luck.